Hello dear students, welcome to Learning Chemistry is Easy and Fun. Today we are taking up introduction of some new terms like molarity, molality, strength and the relation between them. These terms you would require for your experimental work, that means your laboratory work as well. So please make sure that you understand them, you are able to relate to it practically, and the most important thing, you are able to handle the numbers associated with them. So we need to do a lot of numericals. So first things first, please get a pen and notebook ready so you can have your notes for the session ready by the end of this lesson. A solution is nothing but a combination of a solute and a solvent, a uniform mixture of a solute and a solvent. The solute can be solid, liquid, gas. The solvent can be solid, liquid or gas. We are not going into the details of the types of solution. But how do we express the concentrations of these solutions? Concentration means basically expressing how much of the solute is present in a given amount of the solvent. There are various ways of expressing it, and we have written the formula for, I have written the formula for only one of them. Let's see what it is. Percentage. Now you're very familiar with this symbol, percentage, right? What do we mean by percentage? Percentage means out of 100, right? So if in your next chemistry test you get 8 out of 10, what is your percentage of marks? Very good, 80%, and I'm sure you will do it, you'll get it, right? So when we express the percentage by weight, that means we are accounting for the weight of the substance, right? So how do we express percentage by weight? As the mass of the solute present in a given mass of the solution expressed as a percentage. Percentage means we multiply it by 100, right? So the amount of solute present per 100 grams of the solution. The very important point over here to be remembered is solution. In all the definitions, 6 definitions that we are going to do, you have to be very careful whether we are talking about the solution or the solvent, because solute would most of the places be the same where it is, that is in the numerator, but where are we using solution and where we are using solvent, you have to be very careful about it. When we are saying percentage by weight, that means we are talking about the mass and the mass. If I say the same thing, percentage by volume. Now, can you define the percentage by volume on your own and write the formula for percentage by volume here? Go ahead, try it yourself. Percentage by volume, as I have written over here, volume of the solute upon volume of the solution into 100. Now, you must be wondering what units are these expressed in. We have the SI system which we introduced, but what units are we going to express it here? Here, if you see, the units have to be the same because it's a ratio expressed as a percentage. So if you are taking the mass of the solute in grams, you're going to take the mass of solution also in grams. If you are taking the mass of the solute in milligrams, you take the mass of the solution also in milligrams. So it expresses as a ratio, and that ratio is expressed as a percentage. What units will you use for the volume over here? Again, please don't forget that in the above formulas, we express the solute and the solution in the same unit. It can be any, it need not necessarily be in kilograms, because the volumes that we deal with in the laboratory are usually very, very small. So we cannot talk about in terms of decimals in kilograms. So what do is we do express it in grams, milligrams, right? But make sure that the unit of the solute and the solution is the same. The third definition that we are introducing over here is strength. This is what you are going to most commonly encounter in your laboratory work, where we prepare solutions of different strengths. You get a hint from this unit that I have put over here. Strength in gram per liter. What do we mean by strength in gram per liter? This simply is the mass of solute in grams divided by, yes, the volume of solution in liters. Very good. Are you noting down the definitions? Sometimes you are also given this strength in gram per cc. So you have to be very careful about what unit you are using, because this strength we are going to apply in our further definitions as well. So don't be worried, because you know the relation between liters and centimeter cube. So it's 1 liter is 1000 centimeter cube, or which is also in short called as cc, centimeter cube. So don't worry, there's another addition to your knowledge. So let's go on to express the concentration in terms of the other values as well. Normality. Now, this is a term which is being covered in some syllabi and not covered in the others. I will just introduce it. If you are not keen to know about normality, you can skip to the next definition as well. What is normality? It is the number of gram equivalents of solute in a given volume of solution expressed in liters. So what do we mean by this? Gram equivalents. Now, what is this gram equivalence? You remember gram molecular weight or gram moles? It's something like that. Gram molecular weight of a substance. That means the weight of the substance expressed in grams divided by its molecular weight is number of moles, right? When we say gram equivalent weight, that means the weight of the substance divided by its equivalent weight. Now, this is a very new term for you. Don't take tension about it, just stay relaxed. We will do it later on in the video. Number of gram, that means the number of gram equivalents of solute divided by the volume of, again we are talking about solution expressed in liters. As I said, number of gram equivalent means the mass of the solute in grams divided by the equivalent weight of the solute, right? Now, what did we have? Mass of solute in grams divided by the volume of solution in liters. What did we call it as in the previous definition? Very good. It was called as strength of the solution in gram per liter divided by the equivalent weight of solute. Right? So you've got 3 formulas in place. If you understand the basics, you can do with even one formula. In fact, you don't need the formulas at all. But if you are one who is more comfortable with formulas, you can note all 3 of them down or just one of them down and know how to derive the others. As I said, equivalent weight. I will give you a simple idea about equivalent weight. What is equivalent weight? Is the molecular mass or the molecular weight divided by the number of replaceable positive or negative charge. Simple. This is the easiest definition that I have given you. For example, if I say equivalent weight of H2SO4, that is its molecular mass 98, you would divide it by the number of replaceable positive charge, that is 2. So, the equivalent mass of H2SO4 would be 49. Equivalent weight of, would you like to do magnesium hydroxide? So, it would be its molar mass, that is its molecular weight, divided by the number of replaceable positive or negative ions. So, that is again 2. This is the simplest way. We shall deal with it separately if it is required by your curriculum. Do let me know if you want me to cover it. Let's go on to the next definition. Our next definition, that is the fifth one, is molarity, which is expressed as capital M. Simply defined, if you see molarity, please be very careful about the alphabet that I am using over here, MOLARITY. Number of moles of solute per liter of solution, or number of moles of solute in a given volume of the solution expressed in liters. Whichever way you can define it means the same. Molarity, number of moles of solute divided by the volume of solution in liters, correct? Now, can you expand the term number of moles of solute, or just talk about number of moles? What is number of moles? If you've been following and if you've been regular in your study, you'll know what is number of moles. Very good. That is the mass of solute divided by the molar mass of solute. Go ahead and write it. Multiplied by the, again very careful about where we are using solute and where we are using solution. Volume of solution in, again, liters, right? Now, what is the third formula that you can write from it? Again, you know, mass divided by volume of solution in liters. What is it equal to? Very good. So, we have the third formula. If you are a formula fan, then you have the third formula in place, the strength expressed in gram per liter divided by the molar mass of what? Very good. It's the molar mass of solute. Please don't forget here. In the first definition, you've got the solution over here. That's the volume of the solution in the first formula. Whereas when we bring it down to the last formula, it's strength divided by the molar mass of the solute. So, have you got these three formulas in place as well as the definitions? Why don't you just pause the video and try to learn it and understand it and embed it and rewrite it now itself, so as to make your knowledge base stronger, so as to be confident in this topic? Give it a go. Continuing with our sixth term for expressing concentrations of solution, molality, which is written as small m or molal. Understand the difference. L-I-T-Y, not R-I-T-Y that we had in the previous definition. It's molality, and we express it as molal or small m. The difference is in what you are taking in the denominator. It is the number of moles of solute per kilogram of the solvent. Till now we have been talking about solution. This is the first definition where you're talking about the solvent. Now, I've given you the definition. Why don't you pause the video and try giving me two formulas, at least two formulas from this definition that we've given you. Go give it a try. I'm sure you will love to check your answer. I am going to give you the answer, but please pause the video, press this button, pause it, and then try doing the question. I know you're waiting for the answer. Why don't you give it a try? Molality. Yes, number of moles of solute present in per kilogram of the solvent. So we have number of moles of solute divided by mass of solvent in kg. But in the laboratory, we usually do not deal with such high weights. So what do? Let's convert it into simpler form so that it's easier for us to relate to. So we say number of moles is mass divided by molar mass. That's easy. Mass of the solute in grams divided by the molar mass of the solute into, instead of taking the mass in kg, we take the mass of the solvent in grams. But the definition says you have to take the mass in kilogram. How do we convert gram to kilogram? Very good. We divide it by 1000, which goes in the numerator. If you've got these two formulas right, why don't you give yourself a big smiley, the first one of this lesson? Got it? So molarity, molality, different terms. Correct? Now, let us see what is the relation between them and why do we need the two of them. There's a big difference. We are talking about the mass of solvent in kg. You see, when there is a change in temperature, simple example, if you see, if I heat beaker containing salt and water, okay, now I've got some salt dissolved in it and there is water. Now what happens over here? When you heat this or when the temperature is changing, water will evaporate. Now the density of water is 1 gram per cc. So with change in temperature, the volume changes appreciably, whereas the mass does not change much because we are talking about the mass of the solvent over here, right? So the mass of the solvent does not change appreciably. Thus, molality is not affected by change in temperature, unlike molarity, where you are talking about the volume of the solution and which will get affected by change in temperature. So when we are talking about change in temperature, expressing concentrations at different temperatures, molality is preferred over molarity. Are we ready for the next level? Oh, many things to digest today, right? Why don't you take a sip of water and then continue with the video? We are next deriving a relation between capital M and small m, the big bro and the small bro, right? The big brother here, the small brother. Let's put down the formulas that we have learned till now. M, capital M, is molarity, mass of solute divided by molar mass of solute into volume of solution in liters. Now mass divided by molar mass is what? Number of moles of solute, right? I have missed out the solute part in it. You can probably correct it. So this is number of moles of solute is M into volume of solution in liters. Simply molarity multiplied by volume of solution in liters. Correct? That is our first formula. Second, molality is mass of solute divided by molar mass of solute into mass of solvent in kgs. Again, mass divided by molar mass is, yes, number of moles. So number of moles of solute again can be molality into mass of the solvent in kg. So if we are talking about the same solution, then these two values represent the same thing, right? The number of moles of solute and number of moles of solute is molarity into volume of solution in liters equals molality into mass of solvent in kg. Oh my god, we need so many values, but most of the times we see that these values are, all the values are not provided. So how do we determine one from the other? Let's go about it. I've written the formula again. Now, the thing that we need over here is the density of the solution, d gram per cc. That means we've got V. So, if we've got VCC of the solution, that is, this is the volume of the solution provided to us. So, the mass of the solution would be density into the volume, right? Mass is volume into density, you've been learning from your class 6. Now, mass of the solvent would be what? Simple, mass of the solution minus the mass of the solute. What's the mass of the solution we've got? V into D, very good. What's the mass of the solute? That will be the number of moles into the molar mass of the solute, correct? Because we know that the formula of number of moles is very good. It is the mass divided by the molar mass gives us the number of moles. So, number of moles into molar mass will give us the mass over here. So far so good. But V into D is for the solution and we've got the number of moles. So, how do we get the number of moles over here? We don't even know that. So, let's come back to the basics. That's why I said, if you understand the basic logic behind the definition, you won't have to memorize. So, molarity means I've got m moles of solute in 1 liter of the solution. If I say a solution is 5 molar, that means 5 moles of solute in 1 liter of the solution. If I say a solution is 0.01 molar, that means 0.01 moles of solute in 1 liter of the solution, right? So, we know the volume of the solution, that is 1 liters, but our density is given in per cc. And earlier I told you the relation between liters and cc, 1 liter is 1000 cc. So, 1000 into the density gives us the value of, yes, V into D. This is what we've got over here, volume into density. And what about the number of moles? M moles of solute. So, that's the number of moles into the molar mass of the solute. What does this all lead to? It gives us the mass of the solvent. All utterly confusing. What is happening over here? Mass of solute, mass of... Oh, very confusing. That's why I say keep a pen and paper handy. Write it down. Try it yourself. And you will find that it's so easy to understand if you write it yourself rather than just keep on looking at these slides. Go ahead, write it, then you will know what we are doing. I could have easily given you the formula, but you need to understand the fundamentals behind it. Now, we've got this mass of solvent which is there in what unit we'll get? We will get it in grams, right? Because we are dealing with everything in gram per cc. But what is our formula? Mass of solvent in kg. So, what do you do over here? Go ahead, write the final formula. So, we've got molarity into volume of solution in liters is equals to molality into 1000 D minus m into molar mass of the solute. M is molarity, right? Whole thing divided by 1000, right? Because we said that we have to take the mass of the solvent in kg. Now, because we are talking about molarity, we've got the volume of the solution in liters. We are talking about 1 liter of the solution, right? Because we are taking m molarity. Now, the 1000 comes in the numerator. So, you could easily use this formula or the formula that we are going to write over here. So, we've got m into 1000 divided by 1000 d minus m into molar mass of solute is equals to molality. Most of the places you will find this formula again. So, if you are a formula fan, you can go ahead and learn this formula and put the values. If not, then please apply the logic that we have used in the derivation over here in order to solve the questions related to it. How are we going to use all this? So, we are going to do numericals based on this, questions based on this in our next video. But before we do that, I would like you to practice the above formula, and if you want, you can go ahead and practice a few questions as well on your own, because we will be dealing with different aspects of this knowledge that we've gained in the video to solve the numericals. Stay happy and stay healthy. Take care of your health. Don't forget deep breathing. See you soon.